Okay, so this is a quick demonstration of starting up some cookie cutter based applications and just showing how they link together with events and event spy. So if I start off on application realms and create a new realm, my demo realm, and start that realm up on node 1. So I now have a running realm with an attached worker. If we go down to Docker and images, and I create a container, I'm going to call this my demo container. I'm going to start this on my new demo realm. Okay, so in containers we now have a new running container, and if we have a look at the console, this is a basic cookie cutter application. It publishes an event every 5 seconds, which can be picked up by another application via PubSub, and it's registered a single callable topic that you can call from another instance via RPC. So if we take a look at Event Spy and we connect to the demo realm, you can see it's picked up the one registration that the application is advertising and the subscription that it's publishing to. So if we click on that and subscribe, we've now subscribed to the one topic that the application is publishing to. So you can see this is up to count of 32 now. If we have a look at events, these are the events that are coming out. So 35, 36, 37, and these are the matching events being shown on the console. So if we do a similar thing and start another instance, this time on node 2. Demo container 2, start it up on the same realm. Okay, if you look at containers, there's our second demo container. So look at the console. Okay, it too is outputting on the same topic as the first one. So if we have a look at Event Spy, the events, you can see we now have 2 different events coming in with different sequence numbers. The original is up to 64, and the new one is up to 13. So these are coming in alternately from the 2 different instances. On the registration side, they're both registering the same topic, but they're doing so on a round-robin basis. So if we call that topic, all it does is add 2 numbers. So if we do 10, 20, and 10, 21, this is the result it's going back. So on calling that twice, one will have come through the first instance, and the other will have come through the second instance. Okay, so what we can also do, if we have a look at the first container and click on the cog icon, we can start a shell inside that container. So this is the running command, and this is our shell session. So if we have a look at the source code, does it have VI? Probably no, I don't. So I can treat this as a normal container, do an apt update, because it's probably a very basic container with very little inside. Install a basic editor. This all the while is still running and outputting as it should do. but this is accessing the same shared file system as the application that's running on the console. Okay, so that's done that. So client.py, if we have a client.py, just to make it noticeable, we'll change the initial log message and save that away. If we now do a restart, okay, it switched us back onto the main container. It's kept us connected. So there's our new initial connection message. So what we can do, or what we have done, is essentially started a shell session inside a running container, modified the source code for the application that's running, and then restarted it with the session still open. So just to show you again what that does, while this is running, if I do a restart, that's actually restarted the container with the new source code, with the terminal session still open. So you can effectively, if you want to, develop and debug inside a running container. So if we do that again, change something else just because. The console, make sure we're tailing it, do a restart. You can see there's our change just there. So you've got end-to-end development within the running container, and your restart time when you change the source is milliseconds. And if you're still following events, then these are still coming through inside the user interface. Obviously, every time we reset the application, then its event counter is going back to 0 again. Let's just unsubscribe from that for now. Otherwise, we're going to end up with quite a large event table. Okay.